guess you all are electrical EC and BTech, MTech. So I think mixture of all the years. So that's good actually. And today we'll target about many things, but which at least you should know about VLSI. Just a second. Why it is not taking? Huh. Huh. Oh. Okay. So VLSI and how you can come up with the bridge on campus to corporate, and what is the necessity, what is the requirement, why it is so hot, how AI impact, what about the market requirement, and many things we will cover. Okay. So first, initially, I want to give a brief idea, and you will really enjoy. So just will I will come up with the requirement. So let us suppose this this is nothing but a system, and which is a mechanical system. And the best example of a mechanical system, or any, you can take it as a counter. Now what's a counter? Counter is something which counts something. And I think you saw many times this mechanical counters, right? It's just a circular motion of some numbers or something like that. That means a arrangement in which what is happening, digits are rotating, something like that. Something like that. Okay, so 0 1 2 dot 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 9, 0 1 2 dot 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 9, 0 1 2 dot 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 up to 9. So first it will go like that, 0 0 0 0 0 1, then up to 9 it will go. Then after this 9 it will hit the second digit, then it will be 0 0, then sorry, 0 0 1 0, then 1 1, like that. So that means mechanical counter. Sometimes you saw in the big bazaar or somewhere, the security guard, they have a mechanical counter and they need to press a button and it will increase the count. So this is the one example. Now what happens, this mechanical counters can be designed by anyone. Okay, even you can design your own counters. You can take a stick, you can take pen, paper, whatever you can do. Okay, so you can take something like that. But what happens in this, design will become easy. Design will become easy. Okay, so design will be easy. But what happens, there are some disadvantages, or let us suppose not say disadvantage, but this have very less features. What are the features? If I will ask you to check yesterday's count, you will not able to check. That means there is no memory. There is no memory in this. No memory. Okay, so there is no memory in this. So if you remember, or if you know, for the that jumping, we use such type of things, right? So here also we saw some counters. Okay, so that means it may count how many jumps you did. So you cannot check for the yesterday's count. That means there is no memory, and that is also example of mechanical counters. So what happens if we will move towards electronics gadget? So they have many features. They need power supply. They can store the counts. Okay, that means what happens. So electronics, if we'll go with the electronics, they have lots of features. They have lots of advantages with respect to mechanical in the electronics. Okay, you can store. You can store. No need to press something. They can sense. They can sense. They can take through sensors. आपको प्रेस करने का भी जरूरत नहीं है. They can sense something. Okay, so there are many features, but the thing is, the design is too complex, because you cannot design. If I will ask you to design electronics counter standalone, so you cannot design. You need too many things. You should know about the gates, you should know about the electronic circuit, and uska chip fabrication, everything you should know. And that is a time taking and too complex task, but we have many features. So what we know, this is a mechanical counter which we can design the things which we have from nature. Directly we can design. But if I will talk about the electronics gadget, So as someone who is not an engineer or something like that, so you cannot design. So this is a gap. Now what we want to cover this gap, and I will just give you idea how we can go from the requirement to original circuit. So let us suppose we have a requirement in electronics. That means we want a counter. And counter you will get in the form of IC. So this is our requirement and this is our final one. What we want. This is our final one. So this is kind of IC or processor, you can say. So whatever idea we have, that should be available in terms of my IC. That means this is a counter IC. It is like that. Now what happens? So what you have to do first, equivalently for this counter, you should have a digital circuit. Now that digital circuit will have many gates. In terms of gate only, you will found the digital circuit. Now what is this? So second, why it is so what is this? This is nothing but a basic gates. These are the gates. Now what happens if I will talk about, are they available?
Yes.
Okay, sorry. So still if I will talk about this, so these are the MOSFET and they are also not available from nature. Then if I will further zoom in, then what will found? So this is kind of the fabrication of MOSFET, and whatever things you will use to fabricate this, they all are available from nature. So they all are available from nature. So like that, we need to go first from the nature. We will just get this fabrication. Then we will made some gates. Then we will get some digital circuits, and like that we will come up to here to this requirement digital circuit. Now let us suppose we have this digital circuit, and that is all we have in the fabricated from the nature. Now we need to go directly with this IC. So we need to make this IC. So can we go directly? Answer is yes. You just need to make a connections. Whatever circuit you have a equivalent MOSFET, you have equivalent construction or fabricated one. Then you need to just arrange them, and you will get this IC directly. But what happens? If you will 1 minute? Now it won't have an issue. Sorry. So I just mentioned, if you will go directly. So if you will go directly, if you will just use the things, and if you will fabricate a IC just by making connections, then there are two possibility. Either our circuit will work properly, or it won't work. And it might happens not working means it will work only for the 70% case, 80% case. That means not work for the 20% case or 2% case. Not working means not working. So what happens in this case? So we will come to know we wasted our time and money. And when I'm saying money, so that means lots of money. Because if you will check the guy who is working on the fabrication, so they have a average package of 2 3 4 crore cr. So that means lots of money will waste. Okay. And time as well. So what we can do, instead of going directly, we just make sure before fabrication we may add one step. What we can do, we can verify the functionality. How we can verify? We will just take our gadget, Okay, and then we will try to give some inputs, and then we will see counter is working properly or not. And if it is not a counter, if it is a adder, then we will try to give some two values. Okay, let's suppose this is a adder. Let's suppose this is a adder or multiplier or calculator. So we will give like 2 and 7, so it should give 9. We will give 3 and 6, it should give 9. Something like that. So we will manually verify. Now what happens if we will manually verify, then the chance of not working will reduce from 20% to 0%. That means it will work for 100%. Then what happens in this case, we will save our money as well as time. Right? Now we have a further problem in this. When I mention verify, so verify means how we will verify. So we will manually verify. We will manually verify. Now, manual verification, if you will do, then up to what level you can do a manual verification? I guess you can do for a adder, you can do for a multiplication. Okay, some basic operations only you can verify manually. But if the functionality will increase or the complexity of the circuit will increase, for example, if I am taking example of, let us suppose, i20 processor. सर i20 प्रोसेसर तो अभी आया ही नहीं है. हाँ, तो जो आया ही नहीं है वही फैब्रिकेट होगा, उसी का टेस्टिंग करेंगे ना. So if let's suppose Intel i20 processor, so can you imagine, can you verify that manually? Answer is completely no. बिकॉज आप एक प्रोसेसर की फंक्शनैलिटी को आपने पूरा लाइफ में यूज भी नहीं करेंगे, लेकिन उसको आपको वेरीफाई करना तो बहुत बड़ी बात है. राइट? जैसे कैलकुलेटर में सारे ऑपरेशंस आप कभी यूज भी नहीं करते हैं, लेकिन उनको वेरीफाई करना तो सारी वैल्यू पे वो और भी इम्पॉसिबल है. So that means there is a challenge. There is a challenge. You cannot verify the things manually. So what is next? What is next? So the next is if manual fails at every time, you know what comes into picture? The computer comes into picture. Computer. Computer is nothing but a set of program. That means program comes into picture. So what I will suggest, or how is the flow, then you do not have any choice. What you need to do, through computer you have to go, because it's too complex now. And what computer will do? So computer, what will do? So through computer you need to verify and then you need to fabricate. But now there is a gap. There is a gap. And what is the gap? So the gap is you want to introduce computer and then you should go to the fabrication, that is computer here. Okay, and what you have ready, you have ready your digital circuit. That means in one hand, in left side you have ready digital circuit, in right hand you have ready your computer setup. But there is a gap. Why? Because digital circuit is in the form of gate symbol only. Gate symbol only. And in the computer it is expecting program is nothing but a set of instruction. That is nothing but, in everything is nothing but in the binary 101010, or in the program you can say something like that. एक तरफ हमारे पास गेट्स का सिंबल है, एक तरफ हमारे पास प्रोग्राम है, तो कंपैटिबिलिटी ही नहीं है सर. बिकॉज आप, अगर आपने कंप्यूटर ओपन करके पेंट में ये ड्रॉ कर दिया, सो कंप्यूटर विल नॉट अंडरस्टैंड दिस इज ए और गेट. कंप्यूटर को नहीं समझ में आएगा, कंप्यूटर को एक ड्राइंग लगेगा. देयर इज अ गैप. देन व्हाट वी हैव टू डू, वी नीड टू overcome, or we need to cover this gap. And how? So something we need to introduce between computer and this digital circuit, so that compatibility will happen. So I will write something like that. You need to have something which is nothing but HDL, and what it will do, H means hardware. So hardware, okay, and D means description, okay, description, and L means language. So language, or let's suppose programming language, or let's suppose program. So what you are doing, you are simply taking the hardware and describing this in the program. So HDL एक ऐसा कड़ी है जो आपके हार्डवेयर को प्रोग्राम में डिस्क्राइब कर देगा. So you need this HDL. Why it is required? सबसे पहले तो डायरेक्टली हम जाएंगे तो there is a chance it will not work. Manually, complex functionality is not possible to verify manually. Then we need to go with the computer. But computer will not able to understand those circuit directly. Then we need a mediator, which will be HDL. That means hardware will describe in terms of language, in terms of programming language, in terms of program. So that is why we can conclude here HDL is required in designing of each electronics processor or everything. Is it clear? I think yes. Now we need to zoom in only this part. Up to here, what we saw? We just saw what is the necessity of this HDL. Okay. So now we will zoom in this. Okay. So HDL is required. Now, this is nothing but what is the necessity in the industry for this HDL? We have many types of HDL. They are also having version, okay, pre-version, then next version, advanced version, something like that. But the main category is nothing but HDL. Okay. Also, I just want to cover here why it is hot in the market. VLSI company are giving so much LPA, and from the IIT they are taking, from the top institute they are taking. Okay, some coaching institute also are providing the way from connecting campus to corporate. So why it is too hot? Because if you will find out a category, so you will find out a category. Let's suppose I'm writing 3 category, student category 1, 2, 3. So a one who is expert in the hardware means electronics hardware. So you will find many candidates. Who is expert in the software? That means program. That means hardware means digital. You will find many candidates. So that means if one can be good or a perfect in this, if one can be perfect in this, yes, the count is huge. But if I will talk about hardware plus software, that means you should know digital, you should know as well as programmings. So that is nothing but a requirement in HDL, and that is nothing but and a technology also we known as VLSI. That means how many or the number of gates are introduced in this IC is nothing but a VLSI. That means very large scaling. Okay, so I think you all know about that. I will not go in depth in that. So that means the requirement of this will come from the VLSI, because maximum candidates, they can be good in the hardware but not software, and reverse. That means they can be good in the software but not hardware. But a rare candidate will be expert. When I'm talking about rare, that means I'm talking about expert. I'm not talking about, okay, he is good in the 20%. No, I'm talking about expert means more than 80%. So he should be good enough in the combination of 80%. And this much of expertise in terms of count, we have very less. That's the reality. So that's why industry are looking for those guy, and they are giving a good package. Okay, so we'll talk about many things about this, how the market value and how the market requirement. But the first impression which you should know, that is in front of you. What is the necessity of at least VLSI or at least VLSI candidate? What happens without this? How flow was going on before this? Why electronics come into picture? Why not we are going with the mechanical? So this is the first overview which you should know. Now if we'll talk about one by one, So we'll see something here. Okay, 1 minute. Fine. So here we will see so what we are doing, we are connecting student to the semiconductor industry. That's why I mentioned, because industry have requirements of such good candidates. So if they are expert in hardware, that means digital, but they are not expert in the HDL, that means programming side. So we will help you to go from hardware by taking some trainings on the software side, and you will be the good candidate for which companies or industries are actually looking. Fine. Now, so that is if you know what is VLSI. So I already introduced. If I will talk about this IC, so IC, based upon the complexity or based upon the functionality, they might have many category. Okay, so based upon how the number of gates are scaled, that means, what mean by scaled, that means if I will fix the size, that means 1 cross 1, and if I'm putting, let's suppose, 10 gates in this size, 100 gate in this size, 1000 gate in this side. So what I'm doing, I have a fixed size, but I'm increasing the number of gate. So that means I'm increasing the scaling. That means this is nothing but 1 is to 10 scale, 1 is to 100 scale, 1 is to 1000 scale, something like that. So we have VLSI, LSI, SSI. So small scaling, large scaling, very large scaling integrated circuit. It is like that. So VLSI is nothing but which is latest. That means very large scaling, very large integration. That means the count is too large. That means in the same area, the count or the complexity of number of gates is too large. So we have a specific count as well. Like if it is greater than 1000, if it is greater than 10 to the power 3, 10 to the power 5, 10 to the power 7, something like that. But the main thing is VLSI is latest. That means you may see in the future super VLSI or something like that. You may see. So what will change in this? Only the count will change. Nothing will change. Okay. So VLSI or very large scale. That means very large scale. I think now you understood. Large scaling means the count. Okay. Integration. Okay, refers to the technology of creating integration circuit by combining thousands to billion of transistors in a single chip. So that is nothing but VLSI. And I think the necessity of this I already introduced, because we should go with the electronic circuit, and every circuit we can get in the form of IC only. Okay. Now, what might be the application of VLSI? So wherever you are seeing a memory, whenever you are seeing something IC or processor, whenever you are seeing a wireless or electronic gadget, everywhere the VLSI will come into picture. Okay, if you will see this automation, okay, not automation, automobile. Okay, so what happens, they are using so many sensors, so many gadgets. Okay, so many sensors and so many gadgets. So now actually if I will tell you something different, so what is next? You know what they are targeting in the automobile industry, what they are targeting. I think you are aware about in the car, we have wiring. We have lots of wiring actually. Lots of wiring. We have a speaker, we have headlight, tail light, camera, rear, wiper, ye, wo, XYZ sensors. We have lots of sensors. We have not sensor plus we have lots of wire. We have lots of wire. और कभी कभी क्या होता है, वायरिंग में प्रॉब्लम होना, वायरिंग शॉर्ट होना, फ्यूज बर्न होना, राइट, वायर का कट होना, वायर का बर्न होना. वी हैव लॉट्स ऑफ इश्यूज इन एवरी कार. So what we can do next, we can put a central, we can put a some central processor, and we can make local connections as a wireless. हम कर सकते हैं, क्यों नहीं कर सकते, बिल्कुल कर सकते हैं. हम हेडलाइट है या स्पीकर है, इन सबको क्या कर सकते हैं, एक सेंट्रल एंटीना दे सकते हैं, एंड इट विल कंट्रोल. वायरलेस कर सकते हैं, बिल्कुल कर सकते हैं, क्यों नहीं कर सकते? So what will be the requirement of in this case? So the requirement again is we need this processor. That means this CPU we need. तो ये CPU का फंक्शनैलिटी ऐसा होना चाहिए कि सब कुछ वायरलेस कंट्रोल कर सके. हाँ, थोड़ा सा बड़ा होगा, थोड़ा सा कॉम्प्लेक्स होगा, थोड़ा सा कॉस्टली होगा, लेकिन एवरीबडी वांट दिस. हर कोई चाहेगा, क्योंकि ये रियलिस्टिक प्रॉब्लम है. वायर्स इतना कॉम्प्लेक्स हो जाता है, कभी कभी उसमें उसका वायर का बेकार होना, जलना, बहुत सारी ऐसी प्रॉब्लम्स हैं, right? So it will be a best solution, but how it is possible? It is only possible with this VLSI. Now we have this advanced camera, AI, and then CPU processor, and this remote, and many more electronics gadget. So everywhere we had application of VLSI, everywhere. So now evolution is also, I already explained. So that is SSI, small and medium, then large, then very large. So since 1980 it is. So it's small or medium, they are like 60, then 70, then almost mid 70, then 80. Okay, then 80 at the late of 70 and 80. So they are nothing but leading to a highly complex and powerful electronic devices. And can you tell me why we are going for a large scaling? What is the necessity? हम तो SSI के साथ ठीक थे, फंक्शनैलिटी तो वहां भी था. आंसर इज यस. बट व्हाट हैपेंस इफ यू विल गो विद द SSI? सो चिप एरिया विल इंक्रीज. चिप एरिया विल इंक्रीज. ऐसे समझिए, अगर एक फिक्स एरिया में आपके 10 कैंडिडेट हैं और एक फिक्स एरिया में 20 कैंडिडेट्स हैं, सो व्हाट हैपेंस? अगर उसी रेशियो से आपके कैंडिडेट बढ़ेंगे SSI के हिसाब से, सो चिप एरिया विल इंक्रीज, एंड विच लीड्स टू पावर कंजप्शन. पावर विल इंक्रीज, पावर कंजप्शन विल इंक्रीज, एंड व्हाट हैपेंस, साइज विल इंक्रीज. तो आप में से कोई चाहेगा मोबाइल का साइज अगर डिस्प्ले उतनी ही रहे, बाकी प्रोसेसर का साइज 10 गुना बढ़ा दी? यू विल लाइक दैट? आंसर इज नो. एंड अर्लियर इट वाज हैपेंस. कंप्यूटर का साइज बहुत बड़ा आता था, CPU पूरा अलग आता था. अभी लैपटॉप से हाउ इट इज पॉसिबल? जस्ट बिकॉज ऑफ दैट ओनली. और बैटरी नहीं चलेगा, इतना बड़ा साइज हो जाएगा. तो सो दैट्स व्हाई वी मूव फ्रॉम SSI टू MSI, LSI एंड देन VLSI. और VLSI के बाद भी हम जाएंगे, राइट? VLSI के बाद भी विल गो. ओके, fine. So it is like that. Now how is the ecosystem? So ecosystem, first I will tell you 2-3 main category, then you will come to know how is the ecosystem. So see, for the ecosystem we have few design. So one second. So let's suppose if we need a processor, if we have a project, we need to fabricate a processor. So how is the flow? The flow is industry wise. Some industry are specific to some particular work, and some industry are doing in generic work. Some industry are giving service. Okay, so there are two category, mainly product based company and service based company. Okay, so service based company is nothing but providing service to the product based. So they have their own product, like AMD have Ryzen processor, Intel have i5 and this processor. Okay, Nvidia have their graphics, so they have their products. Qualcomm have Snapdragon, something like that. Okay, so how is the flow? So company will design, company will do design, company will do design some, and then they will do verification as well for that design. Then it should go to the fabrication. So that means some, they are having a foundry, that means fabrication, and then you will get this. Okay, then you will get this. So what happens? Design. So let us suppose something is has to design and it has to verify, so let us suppose AMD. Okay, AMD, so they are doing design and they are doing verification as well, AMD. But how they will verify? I mentioned they need a HDL. Okay, so they through computers only they will verify. So they need some software. They need some software in the verification based upon that HDL, so that that software having the library of HDL. So they will use. So in so to use this, some company we are having, so they are just creating or they are just having their tool. Their tool. That means EDA tool. EDA tool. So and those are Synopsys, Cadence, and Siemens, which is known as Mentor. Earlier it was Mentor, now it is acquired by Mentor. Oh, acquired by Siemens, right? So they will have a tool as well. Fine. One minute. So if you will see here, so this is chip designing. This is chip designing. Okay, and chip makers. So here you can see ARM we have, okay, which are making IPs. ARM we have, and processor Intel is making, AMD is making, NVIDIA is making, wireless mein Qualcomm, MediaTek, Broadcom are there, and automotive. So they have their own products. Okay, and now after doing designing and they have to do verification, so we need to go with EDA. We need to go with EDA. So EDA, the tool will provided by the Synopsys, then Siemens, then Cadence. And when designing will complete, and they are giving services as well. I mentioned the service. So Capgemini, Accenture, TCS, L&T, Wipro, HCL, they are providing service. Now what happens? It will go to the fabrication. Then we'll go with the foundries. So TSMC and Samsung, they have captured global market, TSMC and Samsung, but this global foundry and many more. Okay, they are also. Then after this, you will get a processor. After that, you will get a processor. So you have a many scope. Okay, you can go with the EDA. You can go with the IP product design services. You can go then which are making chips directly. You can go with them. So these are the ecosystem for entire VLSI. So you can fit yourself in anywhere. All are good scopes. Fine, something like that. Now, how is the trends in the VLSI industry, right? So if you will come to know from the market or your neighborhood, so they will, if you will be in the VLSI industry, they will assume you are in the IT. You are in the IT because you are working on the laptop and everything, something like that. If you are not in the foundry, okay, they will consider you as like you are in the IT. The thing is because you are working on the programming, but they don't know behind the scene. If you are not good in the digital, if you do not know Bluetooth module, if you do not know the wireless, how you will be a VLSI engineer? So you are not actually in the IT. You are in the hardware side. You will be the hardware engineer only. Okay, but we might say semiconductor in the next, okay, it will be superior to IT also. Even currently also it is superior, okay, because we will introduce AI also in the VLSI, okay, and some IoT as well. So that's why it will be next. And even our government is also pushing and promoting everything, so it will be hot in the next decade as well. Okay, so now Huh. So now what is the importance of a VLSI in modern electronics? So now when I am saying importance of VLSI, okay, so in the modern, it may happens or definitely it will be, we will get to know SVLSI. That means something super VLSI, advanced VLSI. Okay, that means scaling we will increase. I'm not interested in the name. Even they proposed, they have some standard name as well. It is not approximately I'm saying, they proposed some name as well, I know. Okay, but the thing is, what I want to say, definitely size will increase. Even Japan is introduced, even they commented, they will give invisible technology. That means a processor is something they will give which will exist in physical, but a human cannot see. just by normal eye. That means invisible technology they will give definitely. Okay, so what happens with this? Okay, performance will increase and power and size should be reduced. So power and size should be reduced and performance should increase always. So it will help in the next decade as well through this VLSI. If you will see from SSI to VLSI, what we did, we just increase the performance but reduce the power and size. So that's all. Fine. Now, how is the design flow? So if you will look into this, whatever I explain, if you will look into this, so this is nothing but a VLSI flow only. Okay. But whatever I explain here, this is in generic. This is in simple words. But every term or every step have a valid or a standard name that you can see here. Okay. But the overall flow is same. That means chip specification. What will be chip specification? If you want to fabricate some chip, so first you should have a specification. What will be specification? Let's suppose if you are having a calculator, if you are making a calculator IC, so you should know what are the operations should perform by that calculator. Okay, how many bits, how many digits it should be able to do, something like that. Then next step should be your designing. Okay, so designing of that the digital circuit. So first you need to design and you need to do functional testing. That means functional verification. Then synthesis means they want to recheck whatever you have verified or designed, that is synthesizable or not. What mean by synthesizable? That means can we fabricate that? So RTL synthesis that we have to do. Then finally design for test. That means some time check we need to do. Okay. So you should not deep dive now. So just overall you should understand. Okay, that means the time check they are doing in this. Now what happens after this? After this is your front end. This is your front end and this is your back end. That means sometimes you will come to know this is pre-silicon and post-silicon as well. Okay, so now in the back end, how we are doing? We are worry about the chip area, the size, the power, the floor planning, something like that. That means you know the gates and they have to cover or they have to put in a specific area, in the specified area. Then you need to do floor planning, then you need to do placement and clock check, power check, and then final verification you have to do. Then it will go for the fabrication. Okay, so it is like that, and the same things you will see here as well. So this is nothing but design flow. Okay, and in the physical design is another branch where we will do these many things. So this is nothing but overall that's all only which I already explained, but this is in detail or in depth if you will go, but for now I think it is not required. Okay, so now job profile. So I already mentioned this is the entire flow. This is the entire flow, and these are the industry. You can fit yourself anywhere. All are good, all are having opportunity, all are having equal value, equal weightage. Even foundry is having too much weightage. Okay, so so according to your interest, according to your availability or your skills, you may fit yourself anywhere. But the main category is based upon this front end and back end. Okay, because the skills should be different in the front end and back end. Because in the front end you will be working on pre-silicon, in the back end you might be working on the post-silicon. You can see here post-silicon validation engineer. Okay, so here you need to work on the timing checks, on the floor planning, on the physical designing, synthesis. In this you need to work. But in the front end, you should work only on the RTL designs, then FPGA and verification engineer, design verification engineer, something like that. Okay. So based upon your interest, your skills, you may fit yourself anywhere. All are good. Now, other jobs profiles are also we have analogs as well and we have fabrications as well. I mentioned fabrications are superior than this, because they have very less company. Okay, so opportunity will be difficult for you. So you can check with the opportunity. If you are finding yourself good in the fabrication, then it's good. Okay, it's very good actually. But you can just think about we have less opportunity. Then it's up to you only. Now we have some misconception. Okay, what happens? Salary is low, AI आएगा, job जाएगा, recession is permanent, working industry is boring, repetitive, career work, something like that. So here, I just want to introduce something. If you are talking about AI and ML, who will introduce AI? How AI will come? How robotics will come? Everything is controlled by processor only. Everything is controlled by processor only. The memory, the cloud memory, everything is controlled by processor only. And how processor will come? Only from this VLSI. So it's actually a loop. Increasing in this AI will increasing the necessity or the requirement of this VLSI. It is a loop. Dependency. Salary is low. So relatively, which companies are providing service? So it seems you are getting relatively less salary, but actually it is not. How I will explain this? So let us suppose someone someone who is working here in the Samsung, and he is getting 60 LPA, and someone who is working in the, let us suppose, Wipro, is getting 15 LPA. What happens? Actually, this candidate should get 60 LPA only. For example, let's suppose this candidate is working for this Wipro, but it is not doing work of Wipro, it is doing work of Samsung only. But Wipro is providing service. So what is happening? More than 50% or 50% commission only Wipro is taking. And that's why he is getting that much of part. So in that sense, you might feel, or someone might say, okay, these candidates are getting relatively less, but actually it is also not less. Okay, so then that means VLSI industry. That means you can see who company. Do we have any other company? Okay, इनसे भी कोई superior है? Answer is no. Google, Apple, Nvidia. So they are superior, right? तो इनके बाद तो कोई कंपनी ही नहीं है. Microsoft, Amazon. So who will pay more than this? I think no. In the private industry or in the government, तो हटाई दीजिए. So you will not get a pay more than this. So that means in terms of pay also this is superior. Okay. So working is boring. Answer is still no. So I think I already explained. This is too much interested, because if you will change the IP, if you will change the blocks, you will come to know too many things. So you will have a really interest. Okay. So average college students are not eligible. Answer is bilkul no. Answer is no, because they just want hardware plus software skills. And if you have, so then definitely they will capture you immediately. Okay. So MTech is compulsory to start a career in VLSI. Answer is no. If you have MTech, so they will consider you as a 2-year experience, and they will give you, in terms of designation, they will give you engineer 2 or T2 level. But it is not like that you should have MTech. Okay. Only if students are eligible. Answer is no. You can have EE, you can have BE, you can have electronics communication, you can have electronics key relevant branch as well. Sometimes CS also eligible, but you should be good in the digital in that case. Okay, so internship, you can just go to the product based company, and they every year they will give some intern vacancy, so you can apply there, and then you will be able to found what for what you are looking. Okay, now, so roadmap, how you can go to the industry. Okay, so you can go, you can approach directly to the company, but the chances of going directly will be very less, because it might happen you are not able to meeting the requirement of the company. So that's why. Then what you can do, you can going through the courses as we are providing. Okay, so through VLSI app and YouTube directly, we have free course as well. Okay, and paid course as well, some advanced course as well. So just by doing that, you will be able to achieve requirement for what industry are looking. So that will be good. So like that, you can jump from campus to corporate. Okay. So what happens in this? Just you will be able to develop your skills, and we will also provide referrals. Okay, for the intern as well as for the permanent role. So based upon what course you enrolled, so based upon that, you will get many opportunity. Okay, sometimes direct placement also you will get in the product based company, in the service based company. So we have lots of things. Okay. Okay. Now, which profile is to choose? So, as I mentioned, you can fit yourself wherever you find suitable yourself. But how to, huh, but how to identify that? So, some generic things are there by which you can think on this. For the front end, so it will be suitable for those guy who enjoy fixing a bug and error. Okay, who loves coding part with electronics. That means उस हार्डवेयर का ही प्रोग्रामिंग बना के if you want to enjoy, then front end will be suitable for you. Now back end, I already mentioned in the back end. So in the layout, in the timing analysis, in the floor planning, okay, so in the CAD tool, if something like that, if you are feeling like, okay, I will be interested more in this, then you can go with the backend. In terms of opportunity, in terms of package, in terms of future, I think both are same. Almost both are same. Okay, there is no difference. So what technical skills interviewer looks for? So actually, if we will categorize a design engineer and a design verification engineer, that means DE and DV. So for the design engineer, you should know HDL 100%, 100%. Without that, there will be no entry. But for the design verification, you should know HVL and methodology. Now, what is this HVL? HVL means system Verilog you should know. System Verilog you should know. And in terms of methodology, you should know UVM. Completely you should know. And in the HDL, you should know VHDL or Verilog. You should know VHDL or Verilog. 100% you should know. 100% you should know these two. Now for the backends में many things DFT है, and we have STA and floor planning, physical designing. So based upon that, we have many category, but for now we'll target only these. Okay, equivalently you should have those as well. Okay, so you can see for the design, digital design, you should know Verilog HDL. Okay, for the verification, you should know UVM. For the verification, you should know UVM. Physical design, you should know floor planning, placement, routing, this. And ASIC and FPGA design, synthesis and placement, you should know. Okay, so it's like that only. Some scripting languages also required like Python, TCL, and CCC+, but they are not required 100%. Even 30% is fine. 30, 40, that means passing marks. If you are passing marks is average, one third you should know, kind of. Okay, you should be able to pass. At least you should be able to understand the scripting language. And 20-30% you should be able to write. That's enough. And EDA tool, you should know about the cadence, synopsis, mental graphics, as I already mentioned. Communication skills, and these are okay. Okay, these are not the requirement. At least if you are in the passing marks, okay, 33% is fine. 33% is fine. So that's all. But no compromise with these things. No compromise with these things. You should be 100% in this, or above 80%. 100% means above 80%. That means you should be in the A1 grade. Now, who can opt? I think there is no restriction on the course. Okay, BTech, BE, NEC, electrical, triple E, engineering, physics, you can go. MTech, ME, MSc in VLSI communication, DSP, power electronics. I mean, relevant also it will work. It's not like that. You should be expert in the digital and in the HDL. That's all. Okay. And if you are passionate in the electronics, then you can go. So who is not interested to switch to IT but want to enjoy the same work, or let's suppose coding, then it is the best. Then it will be the best, because here you are doing some hardware work with programming. So that is really good. Okay, you will really enjoy. Okay. So, and higher compensation obviously you will get. Okay. So you can think for this. Obviously, I already told you, we'll say for all we are providing many things. So it will help you to go from campus to corporate. I already mentioned directly you can go, but that will be very difficult. It will not be a bridge. So VLSI for all, we will create a bridge in between campus to corporate. So we'll provide some free courses as well, and some premium courses as well, and job assistance as well, placement also will providing, and mentorship we are providing. Okay, and the bridge, the gap between academic and industry, which I already explained. Okay. So mm, we have many things in this VLSI for all. 1 minute. So we have many things we should not say, but we have live sessions and community 24 mentorship. We are providing doubt sessions also, and many things. Okay, teamworks, and the main thing is this. And uh, 1 minute, mock interview, where we have so this placement opportunity. So these are the main things which you should look, and else we have countless things. Okay. So now these are the alumni also, they are working. Okay, Intel, ST, and Synopsys, Samsung, Mirafera. This is a service based company, I already mentioned na, and ARM, Qualcomm. So just they are working. Okay, and many more, we cannot even count, right? Now so that's all about. We can download the app. We have a app on the Play Store as well, VLSI for all. You can download. Okay, and these are the how you can contact us. So these are the website and email ID and contact, so you can reach to us. Okay, so that's all about this. Now I will cover something. So up to here, if you have any doubt, 1 minute, so you can ask anyone. If you have any doubt up to here, you can ask related to anything. Window is open. So if you have any type of doubt, anything, you can ask directly. Anyone. Any question related to anything, industry, training, requirement, market, package, opportunity, interviews, experience, anything. If you have something in your mind, you can ask. And what I covered what is the necessity of this VLSI, how it is hot, and how it will be in the future, in the next decade, and how VLSI for all is helpful to you. So that's all I covered. So if you have any doubt in this, you can ask. No doubt, no question, anything. If you have, you can ask now.
Can you provide overall the VLSI subject in the tab?
VLSI subject in the what you're saying?
VLSI for all app.
VLSI for all app is there in the Play Store. You can download what you want. Link you want.
The entire VLSI subject can you provide in that app?
Yes,
No,
yes, we will do
actually,
it.
I mentioned. So in the app, what we have, you can see here. So some free courses are there only for beginners. Okay, some test series and many things are there, and we have premium courses as well. So you need to find out you are looking for the premium courses, that means paid course or free course. So definitely we have free course as well as we have paid course. So according to your requirements, only you can get. You
We
got our
can
answer?
start some basics and all. Yeah, we can
Correct,
start
correct.
with very low kind of.
Yeah. So any other query? Anything. It could be anything. Company, market standard, opportunity in this profile.
One person is asking which profile is best for the fresher. Which
For
profile
the
is best for the fresher?
fresher. Okay. So I will take few minutes and I will tell you the actual market story. So let us suppose if this is a IC or this is a processor, and let us suppose we decided it will take 100 days. 100 days from specification to fabrication. That means in total, this IC, let us assume it will take 100 days. And we have our flow as well. Okay, we have our flow as well. This is front end and this is back end. Okay, so mainly I will just split this. This is design and design verification. That's means design and verification. And this is nothing but fabrication. So if you will think on this, almost 70% of time, that means 70 days will require to complete up to here, and 30%, that means 30 days will require here. Now if you will further bifurcate this, then designing will be 30% of 70 days. That means 21 days. That means 21 days will require only in the designing, and 70% of 70 days, that means 49 days, is requiring in the verification only. So if I will talk about in general, let's suppose if you do not know anything about VLSI, then also you can get some idea in fabrication or in making a entire processor, how much time we are spending, or a maximum time we are spending where? We are spending in the verification only. That means out of 100, almost 50%, that means 49% we are spending time only on in the verification. So that means the employee or the manpower is also required here. Here we require more manpower, because ज्यादा काम करना है तो ज्यादा लोग चाहिए, and here we require relatively less. Relatively, I'm saying relatively less, and here also I'm providing relatively too less. That means इसमें सबसे ज्यादा, इसमें सबसे कम चाहिए, इसमें सबसे कम चाहिए. Okay, and also if I will talk about on the designings, I think up to here it's fine. So now you can think on it. If a company is spending almost 50% time only on the verification, that means their team should also be in the same ratio. Job opportunity also should be in the same ratio. So in that context, अगर मैं बात करूं आपकी job opportunity की, that means if you want to switch, then you can switch immediately because there is a more requirement. So design verification is best. Easily you will get. I'm not saying design is not best, physical is not best, but if you are asking in terms of opportunity, I am telling. So definitely you will be have a opportunity. So let us suppose there are 100 vacancy So 49 vacancy will be for verification, 21 will be for design, and in the physical or in the back end, 30 will be for that. So something like that. It is something like that. So I think now you have enough idea. So if you are a fresher, so obviously you should get more opportunity, right? So then you can go with this verification, design verification. Yeah. So anything else, if you have such kind of questions, please ask. That will really help you. If you want to decide something, if you want to know something, okay, which companies are good, how EDA works, and how their competitor, something like that. The package wise you want to know, there is a difference, opportunity, how which course will help you, which is the basic requirement in this, something like that. If you have, you can ask. Then we'll close this and we'll go through some basics of Verilog.
Which company offering the design verification mode?
Which company is asking? The means they have opportunity, huh?
Yes, sir.
So all company which are I written in this website, oh sorry, not website, in this PPT, you can see. So all are chip makers, na? So they are having their processor. So that means they are doing designing as well as verification. So all, so which you can see here. So these all, these all, these service based also will provide service to this. So yes, and EDA company as well, but with less percentage, because their main work is on EDA tool. But yes, they are also doing same work. So these all company are working on the design verification. So you have opportunity from all. Yeah. So next, anything else? So you can ask any type of question. Don't hesitate and don't think.
Can you give the brief explanation about EDA?
EDA in industry or tool?
Tool.
Okay, tool. So tool is nothing but a software, and that is nothing but a collection of library only. So let us suppose when I said this is a HDL. This is a HDL. So what is this HDL? HDL is nothing but some set of rule. How? Let us suppose if I am writing A and D. If I am writing OR. So I will set a rule like this A and D is nothing but is equivalent to this AND gate. This OR is nothing but it is equivalent to this OR gate. They are not referred to the grammatical AND or OR. So those set of rules, I am calling this as a HDL. But we need to store them. If we need to store them, if we will store them, so where we will store? We will make some library only. Library बनाएंगे ना? And that library we need to include somewhere. So that will called as software. And if this software is related to our designing, then that is nothing but ED. I will show you 1 minute. Ha. So if this software is related to electronics design is nothing but ED and automation. So electronic design automation then will called as EDA. So if we will go, if we will just go to this Google, and if you will do EDA, okay, so this hmm 1 minute. So this is nothing but tool, right? So if you will select here language and library, I already mentioned language and library. So it is asking for, we have a VHDL, we have Specman, Python, C, Perl, CSS, System, Verilog, Verilog. Okay, so we'll select this one. Then it is asking for the methodology, UVM, and this one we need to select this. Okay, and other libraries as well. These are the libraries. So tool is nothing but a collection of library. Because if you will open another software, let's suppose Zoom. So Zoom do not have system Verilog library. You will open the Swiggy. Swiggy do not have system Verilog library. But what about this software? Yes, it has this library. That's why we are using. Now, if we'll go to the tool and simulators, so we'll see here, these are the tools. Commercial tools, Cadence tool, Siemens tool, Synopsys tool. So we can select any tool. That means, let us suppose if we'll go with the Cadence. Okay, so now we have all setup ready. We have all the HDL or HVL libraries, and now we can consume them. If I will write something module TB, which is a keyword, module TB and module. So I will tell you later what is this module and module, but for now I'm telling, we can just write end. So now what is this end? This end is nothing but AND gate equivalent. AND gate equivalent. If I will write here OR, this is nothing but OR gate equivalent. This is nothing but OR gate equivalent. OR gate equivalent. So just because of this library only, it is picking. So this tool is nothing but, so EDA tool is nothing but a collection of library which have all the HDL and HPL and methodology library. Clear? And only in the market, only 3 industry which acquire the entire market, Synopsys, Siemens and Cadence. छोटे छोटे इंडस्ट्री भी हैं, बट उन्होंने मार्केट में नहीं, उनका ज्यादा एरिया है. ओके, सो मेनली वी हैव 3 इंडस्ट्री ओनली. क्लियर है?
Thank you, sir.
हाँ. So like that, if you have any doubts, you can ask. It will be good for you if you will clarify. Any type of doubt you can ask. The window is open to you. Any type of doubt.
Sir,
Yes.
sir, you have told about an app which provide courses. Will that courses be certified?
You will get certifications as well.
Okay, sir. Thank you.
Whatever course you will do, either free or paid or premium, based upon that only you will get whatever you will do. Yeah. So good. Like that only you can ask questions. Any questions you can ask related to anything. You can ask even your like this is gap matters, not matters, years of experience matters. So if you have any kind of doubt, so you can ask. Then I will move towards few Verilogs. Okay, I will take one example. I will first draw the digital circuit, and then I will make a one program, and then I will show you the sample for the same. So shall I go? If you do not have any further doubts.
Sir, while preparing a resume, like it is better to make it like a job specific resume or like overall front end and back end kind of.
No, you should be specific to profile. You
So-
should be you have to decide for which profile you are applying, and you should be, your resume should be approaching to that profile only. Let us suppose if you are preparing for design, so then you should target mainly about very log things. Okay, you should not write the STA, the DFT, those things, because for which you are looking for the designs. Okay, so the owner of that company or the team or the hiring manager is interested only in the Verilog part. So if you are beginner and if you think like I can go anywhere and I have knowledge on this, so you can prepare multiple resumes. One is for design profile, one is for design verification, one is for DFT, one is for synthesis. Like that you can prepare. But you should not write everything in one resume.
Okay.
Okay. So in that case, you have your more than one resume. One is for design, one is for verification. So in the design, you can highlight the VHDL, the Verilog part. And in the DFT, you can highlight the DFT part. In the verification, you can highlight the system Verilog or UVM part. In the test bench also, you should highlight. Okay. So like that. Because in the verification part, if you will not write SV and UVM, they will reject your resume directly. In the in the Verilog, if you will not in the design, if you will not write anything about Verilog, they will reject your resume directly. In the STA or in the physical designing, if you will not write anything about the floor planning, routing, and these things, they will reject your resume immediately. Even you are expert in the UVM, in the system Verilog, but they are looking for floor planning. Now, how it will be helpful? It will not be helpful. So it is like that. So you, in such case, you should prepare more than one resume. But your resume should be specific to that profile only for which you are applying. Make sure.
Yes, thank you.
Okay. So like that, any other doubts? Please ask.
More doubts we can cover in the last of session now, because it's
Okay.
almost like 1 minute over. We
Okay.
can cover rest of the doubts in the end of session, right?
Fine. Okay. Okay. So now we'll take, let us suppose I will, what I will try to cover, I will try to cover a basic example. Okay. In the same contest, I will first take the specification, then I will make the digital circuit, then I will make the design, then I will do verification, and then I will send it to backend team. So whatever happens in the front end, that I will cover with the basic examples. Okay, digital example. So I think we can take mux, we can take anything. Okay. So let us suppose we are taking mux, 2:1 mux. How 2:1 mux is? So what is this? This is the requirement. This is just nothing but a symbol. Okay. So it can be written as y equal to s bar I naught plus si1 plus si1. So this is the requirement. Now what we have to do, we have this block. Okay. So this is our circuit, or not circuit, this is our system actually, for which we are looking now. This is our system. Now, before sending it to fabrication, we need to design this in the program and we need to verify this. So for the same block, we need to write into the HDL. Now this overall block is defined a keyword which is module and end module. And whatever ports this entire block have, the same should be right here. Either they are input, so input, or they are output, so output. So we have to write here. So input is nothing but S comma I naught comma I1, and output is nothing but Y. Now we need to just write the functionality in this. Y equal to S naught this. Okay. So how we can go? We can draw it like that. S should be negate first. This is S bar, and then we should take I naught. Then we should do AND. And then we should take S and I1. Oh, 1 minute. So this is I1 and S. Then we need to do OR. Then it will be Y. So that much of work we need to achieve. How will we achieve? So we have keywords for each gate. I will just write not of S. 1 minute. I will just write intermediate variables, which is W1, W2, W3. These are intermediates. So I will just write what is W1. W1 is nothing but negation of S. Now, what is this end? So end means W2 will have end of W1 comma I naught. So how is the syntax? Syntax is not of out comma in. End of out comma in 1 comma in 2, and dot dot dot. For other gates as well, it is like that. Now I will do another end. So that will be in between W3. It should be W2. W3 will have I1 comma S. Now OR of Y will be W2 comma W3. I think it's clear to everyone. So because we are just using equivalents. Now how tool is come to know what is this not? Just because of library. Now tool is smart enough, or our software is smart enough to understand what is meaning by this NOT, what mean by this A and D, what mean by this OR. So that is why we are using EDA tools. Okay. Now let's see. So I think few of you might aware about these things, but few of you might not aware. So if I will say something to assume for now, please assume. Okay. So let's suppose if I'm writing marks, and if I'm writing here input of S comma I naught comma I1 comma output Y. Okay. So we need to declare actually it's a type as well. It's type as well. So we'll declare or type. I will come to this later. We need to declare some temporary wires as well, which are not input, which are not outputs. So we need to declare W1 comma W2 comma W3. Okay. Now we need to just mimic that. Whatever I written, we need to mimic here. Not of W1 comma S. So what I am doing now, I am just writing equivalent of that digital. So not will provide W1 will be the negation of this S. How I am writing this? Because I know not can be used as out comma in. So based upon that I am writing. Okay. Now next should be end. So how end can be used, I will tell you, but I am using here W2 should be end of W1 comma I naught. How we can use this? So end should be out comma in 1 comma in 2. Okay, like that. Now, end of W3 will be I1, comma S. Okay, so the same thing, and next is OR. So OR of Y, comma W2, comma W3. That means how we are using this. OR can be used as out, comma in1, comma in2. Okay, so like that. Now if you will save and if you will run, so let's see it is understandable by tool or not. Oh, what happens? Uh, oh, we lost that. I don't know why it is. I just saved. No problem. 1 minute. I will just immediately write module. Yeah. So if we will save this and if we'll run, so first it will check whatever we written and the understanding of library both are in sync or not. So let us suppose if I will do some mistake here, I will I will change the spelling of this end. Okay, so this is not understandable by tool and it will give a error. Okay, this is something syntax error. That means it is unable to found in the library. So that is nothing but error. But here we can see there is no error. Hence, tool is completely code is completely understandable by tool. Now our design is error free. Our design is error free. But we did not verify. So we need to verify this. So we need to verify this. How will verify? So let us suppose if you are making LED bulb, okay, you are just fabricating them. So without sending it to the customer, what you will do at your end? You will make sure whatever LED you made that is correct or not. And how will you ensure? So you will just check by giving power supply, LED should be glow. It is glowing or not. So how you will just make sure to provide power supply, you should have a holder. You should have a holder. And that holder should be able to drive the power supply to LED. And LED should be put within this holder. So similarly, what we will do here, we should have a overall circuit. we should have a overall circuit, and that should be test bench, and this is nothing but our design. So design should be under test. So if I will put this here, so it will become DUT, matlab design under test. So our test bench should able to drive inputs to the DUT so that DUT can give output. So our test bench should work as a holder towards LED. So it is equivalent of that only. So I will make sure whatever input is required to my design, I should be able to drive them, similar to LED holder. So what LED holder makes sure whatever input to required to LED, it will be able to drive. That means power supply. So I will write here module test bench means TB and module. Okay. So I will just first take DUT inside holder. So I will just write mux here and I will give a notation mux note or mux 0. Then I will just make connections like we are making connections in between in between LED and holders. So I will just make connections S to S, I note to I note, I1 to I1, and Y to Y. And I need to declare here. Uh, range of S comma I note comma I1. Okay, and I can declare this. Okay, so I can declare this Y also. All right. Now what I will make sure, I will give value to S, I note and I1. I will generate. So initial is a block. You should not focus on the what is this initial, what is this begin, what is this end. These are the syntax, and I think many of you might know. But we'll focus on, we are focusing on the overall flow, because doesn't matter it is a small circuit or it is an entire processor, the flow will be same. Here we are writing only 7 case, only 7 line. But if it is a designing for a processor, so it might have 7 lakh, but the overall flow will be same. So here we will make sure first we'll provide S equal to 0, then I equal to 0, then I1 equals to 1, and here I0 equal to 0. Okay. Now what we will do after providing this, we will do some display. Dollar display. That means we will verify, or through waveforms also we will verify. So we'll just do dollar display. 1 second. S equal to %0D, I note equal to %0D, I1 equals to %0D, comma S comma I note comma I1. Okay, and then Y equal to %0D comma Y. Right. This is fine. Let's see. Oh, display is spelling mistake display. Yeah. So what we can see here, if we are giving S as a 0, so I note value should come, and which is 0, and we are getting 0. Now let's make I note as 1, because we should test both the case. Yes. You can see here when S is 0, so I naught is reflecting to the Y. And we'll check for the S1 as well. Then I1 should reflect at Y. So now if S I will make as 1, okay. So I1 should reflect. I1 should reflect. So you can see here, when S is 0, I naught is reflecting. When S is 1, I1 is reflecting. So that means what we can say? What we can say, whatever we are designing here, this is equivalent of the provided circuit. So can I 100% comment if there is no fault in the fabrication, it will be a accurate 100% accurate circuit for mux? Can I comment? No response? I think yes. Okay, we can comment. So that is nothing but verification. Now, if you want to see the same thing in the waveform, if you want to see same thing in the waveform, then also you can check. Just a second. You need to put one keyword that is for waveform only. 1 second. Okay. So you can get the signals, okay, and you will come to know. 1 minute. Yes. So you can see the combinations here. When S is 0, I note is 0, so output is 0. In this case, S is still 0, but I note is 1, so output is 1. When S is 1, so whatever value we have at I1, so that is following. So even if it is a complex circuit, let's suppose if it is a for FSM, it is for vending machine. So similarly, we can check if it is a flip-flop, that also we can check through waveforms. So now after verification, so now we can say whatever circuit we have that is verified, we can send it to the backend team. Now they will do first synthesis. They will identify whatever you use in the design that is synthesizable or not. Based upon that, they will just forward it to the floor planning and ST, that means physical design team. They will just pass it out. So any of you have any doubt in this flow, you can ask. Then I will go one step ahead. So how we started, we just took one digital case, then we have equivalent, then we made a coding, then we verify, and then we just transferred it to the backend team. So any one of you having doubt in this, you can ask. Anyone? Fine. Anyone have any doubt? No doubts? 1 minute. One minute. I need to remove this. This one. This one. Yeah. So no further doubts. So if you will see the same thing, let us suppose we will move towards a next circuit. Let us suppose we will take some vending machine. So for the vending machine, how you will think? First, you should have specifications. Okay, specification means how many items you want, for which coins you are accepting. Okay, how many outputs you are having. It is delivering only one item or it is delivering multiple items. Based upon that, once you are done with the specifications, then you should have a digital circuit. How you will have digital circuit for such cases? So from the specifications, directly you will not have any circuit, right? Directly you will not have. So what we'll do in such cases, we will just have a FSM. For this vending machine, we will have a FSM. Then with this FSM, we will have state tables. We will have state tables, which will have some inputs and outputs. Now, inputs and outputs can be related like that, y0, y1, y2. They can be function of inputs. They can be function of inputs. And if you have this, then immediately what you need to do? You need to just round a module. You need to just round a module and a module. And you need to capture those things here. Then you need to make a test bench. And inside test bench, you should put this. And you need to verify. But what happens if you will go to a large circuit? Every time this will not work. That means it will be a difficult task to write everything in terms of equation. To write in terms of equation, it will be a difficult task. So that is why Verilog have more than one types of designing. What mean by type of designing? You can design either at the gate level, okay, or in the behavioral level, or we have one or two ways more. So what I want to explain here, do we have any other way we can design same circuit without knowing the equations? Answer is no. Oh, sorry. Answer is yes. How? I will explain. So we can design our circuit based upon its behavior. What mean by behavior? Behavior means functional behavior. How it is functionally behaving. So if you remember, I already mentioned what is the behavior of this mux. The behavior of this mux is if s equal to 0, so y is following I naught. Else if s equal to 1, y is following I1. Is this the behavior? Answer is yes. So if you know the behavior, you do not need to require all these circuit and all these things. directly you can go with the behavior. Clear? So let's see how it happens. So if I will comment this, and in the same I will write, if 1 minute. So don't focus on the syntax because that you cannot understand for now. Okay. So if s equal to 0, then y should followed by I note. Okay. And else if s equal to 1, then y should followed by I1. Now let's see it is working or not. Let's verify. And don't think every time it will give the correct value. I will make a mistake in design, then I will show you. So here can you see now our design is correct or not? See, for the S0 it should follow I0, that means 0 1. For 1 it is following I1, which is correct. Now if I will make any mistake in this, let us suppose I am just making this I1 and I0. So now we will not get our can you see here? For S0 it is not following I0. For S1 it is not following I1. That means our design is incorrect. So like that we can check. But what we learn in this and what we saw, we have more than one way to do designings, right? So if I will make this as a I note and this as a I1, that means based upon behavior also we can just do. One more way we have, that is data flow. What is data flow? How data is flowing from input to output, directly we can write. That means I can just write the exact equation, assign y equal to s, sorry, negation of s should be ended with I note, and or s should be ended with I1. Then what happens? That means what I'm saying, please assign y according to this. Like that my data is going to flow. Let's see. So you can see for s equal to 0, y is following I naught. For s equal to 1, y is following this I1. So it is not even fixed. You should go either data flow, either behavioral, or get level. You can have a mix as well. Let us suppose if you have some complex thing, you can write behavioral. You have some direct thing, you can write data. You have some get things, You can write get level modeling. So you can mix for your easiness. So that much of features is provided by this HDL Verilog, and this is nothing but our test bench. Now what we have, so in this case, how we are verifying? We are actually manually verifying. We are verifying manually. This test bench is only driving a stimulus, but our design is correct or not, we only manually verifying. So what we can do, we can made a self-checking test bench as well. That means without looking into the waveforms, without looking into the display messages, we should know either our test bench is correct or not. So I will try to make a self-checking test bench for this case. So first I will comment this display. Okay, without display, I should know our test bench is correct or not without this display. That means manually I will not verify. So how I will go? I will just write. In this case, I will write if s equal to 0, I equal to 0. So I will write here if. So I will write a counter here int I. So I'm taking a temporary variable int. And what I'm doing, for every correct case, I will do I as increment. I will make an increment in I. So I will write if y equal to 0, then I will do I equal to I plus 1. Okay. And here, if I will write if y equal to, that means what is my expectation? That means what is my expectation? My expectation is, in this case, if design is correct, so I'm expecting I should be 1. If I equal to 1, then I will do I equal to I plus 1. I equal to I plus 1. But here what I will expect? I will expect it should follow in the y1, then I will do 1 correct, which is correct. And here also it should be 0. It should be 0. Now at last what I will write, if I equal to 4, then what I will write? $display data matched design passed, but else what I will do? Else what I will do? Data mismatched, design failed. Design failed. That means what I did? I just put a checker. So can you see? Data matched, design passed. But now if I will make changes in the design, let us suppose I will remove this negation, then my design should fail. My design should fail. Data mismatched, design failed. Now if you want to check by how much count design failed or by how much count design passed, so you can just print here design failed with with %0D matched case. That means it will show you the count of matched case, and which will be percentage of I. That means I only. That means it will tell design failed and how many combination matched. It will show you. But failed means failed. So you can see data mismatched, design failed with 2 matched case. मतलब 50% आपका डिजाइन पास है. तो 50% डिजाइन क्यों पास है? You know, because the error is only when s equal to 0. S equal to 1 is working fine. That's why 50%. And if you make here this case, then design will be perfectly working. Design is perfect. I guess you understood the necessity of this self-checking test bench. Now you don't need to worry about the how is the waveform and everything. You just need to worry about this message. Design passed. So any doubt in this? You can come. If you have any doubts up to here, then I will tell you what is next. Is it good to write a self-checking test bench like that, or we have something else? I will talk on that. So anyone have any doubt up to here? No?
No, sir.
Okay, fine. So now what is the challenge in this? Actually, if you will see, so we are saying do not need to verify manually, and we can get this display message directly, either design passed or not. But actually what we are doing, in actual we are manually writing case by case, and that is why we do not need to worry about either design is verified or not. That means manually. But is it really effortless? Answer is no, because you need to put efforts on writing the each case. So that is the issue. So for that we have a extension which is HVL. So HDL is specific to design only. HVL is specific to verification. V means verification. So HVL. So verification language, that means system verilog, will give you a feature to writing a test bench in a very standard order. That means there you have components, there you have a reference model, monitor, drivers, okay, and too many things. We have top, we have driver, we have interface, we have DUT, too many things we have, right? So that is the final solution. That is the final solution for test bench. And if you'll see in the realistic, what mean by realistic? Realistic means in the industry what we are doing, what we are using today. So they are using system verilog only. So that is why I mentioned in that PPT, for that profile, if you are looking for this design verification, so you should know the system verilog. So that is nothing but enhancement. This system verilog, this UVM. So this is the enhancement. Okay, so that you should know. So there you do not need to manually write. Okay, you have actually mechanism to create components. Okay, and many things. So you will be able to write test bench. So now window is open. If you have any kind of doubt, you can ask. And if you want any specific things, okay, can we do this? Can you explain this? So, but that should be a generic. Okay, we can't go specific. So then you can come to me and you can ask now. Now window is open for you. What we saw, the actual process and the actual steps how we are covering for a circuit. Okay, from specification to that front end entire. Okay, the behavioral, how we can go, the data flow, the gate level, the test bench, the self-checking test bench. We have many things. We have task-based test bench, okay, and we have methodology as well. Many things we have. Then I will take a few things on the system Verilog and UVM, how they are important. So before that, I want, if you have any kind of doubts, you can ask, or if you want anything, okay, can we cover that? So I will take that topic as well if you want, or any specific things. Any specific, anyone want? Any doubt till here? Any kind of doubt if you have. No? Related to placement query, anything you can ask, not an issue. How is the market going on? Is such that if you have anything, so you can ask. Else we will have a short idea of the system Verilog and UVM, and I think we'll close. So that's how I planned.
No, sir.
Okay. Others?
No, sir.
Just continue. Just continue, please.
Okay. All right. So as I explained, what is in the SV in the system Verilog? So system Verilog is mainly for verification purpose. Okay. Why I'm saying mainly is for verification purpose? Because first system Verilog is nothing but superset of Verilog only. If this is Verilog, okay, and this is system Verilog. This is the superset, right? Now, what happens? Verilog is used only for design purpose. If it is used only for design purpose, then what is the main things we should keep in mind is only synthesizable construct we should use. Why? Because our design, if we are making design, so whatever we made, there's a design, it should be synthesizable. Why? Because it will going to fabricate. So if you use something like that which can't be fabricate, then it will not be a good design. It will be the wastage of time and everything. जो डिजाइन फैब्रिकेट ही नहीं किया जा सकता, अगर आपने ऐसा कुछ बना दिया, so that means there is no meaning of design and verify. So that means in the designing, everything you should use as synthesizable. But in the test bench is something which will not going to fabricate. Test bench क्या है? Test bench एक temporary चीज है. So we just need to verify that. Test bench will be used to verify design only. That's all. So in the test bench, we can use non-synthesizable construct. There is no matter of using synthesizable or non-synthesizable, because that will be useful only in verification of design only. So there is no meaning. But our design 100% it should be synthesizable, 100%, not even 99. So that is the main thing. So that's why, because it is non-synthesizable, system Verilog have too many features, many features. Let us suppose if Verilog have 30%, so system Verilog have 100% features. Okay, it is like that. So we have OOPS concept, we have class, we have object-oriented programming in this. We have test bench structure, we have self-checking test bench, we have components itself, we have interface concept, we have too many data types. So that's all. So that's why system Verilog is important. Now, if you'll take UVM, what is this UVM? So do you think it is like that only? It is like that only. This is Verilog. This is system Verilog, that means SV. And this is the superset of SV, which is UVM. Can someone tell me it is like that? Can someone tell me it is like that? Yes, no? Third one, UVM. Or no idea? Okay. So this is completely wrong. Why? Because if I will talk about Verilog and system Verilog, so Verilog is nothing but a language. System Verilog is nothing but a language. But what about UVM? UVM is not a language, but it is a methodology. What mean by methodology? Methodology means the way of doing work is nothing but a methodology. काम करने का तरीका is nothing but a methodology. So that means UVM is a methodology which applied to many languages. So UVM means universal verification methodology. That means universal verification, the way of doing work. That means whatever we are verifying, that should be doing universal. Okay, so the way of doing that verification should be universal. So that's why we have a universal. Okay. How it is important in the industry, let me just give you idea. So let us suppose there are 2 employee or 3 employee. Okay, employee 1 and employee 2. Employee 1 and employee 2. One is working with NVIDIA and one is working with Qualcomm. Yeah, something you can take QCOM. Okay, and one is working with the Intel E3. One is working with the Intel. Now what happens? One is working Verilog, and system Verilog. But what happens? These all 3 employee are following their own methodology. Even NVIDIA को follow कर रहे हैं, E2 QCOM को, E3 Intel को. Then what happens after 4-5 years? Let us suppose if E3 switch his job to E1, and E1 will go to E2 and E2 will go to E3. Then what happens? Whatever methodology already used in E1, it is not availed by E3 and vice versa. So that means E3 will be almost fresher. Almost, I'm saying not equal, almost fresher. Because he is not aware of the methodology used by E1. And if E1 will go to E2, E2 will go to E3. That means they will be equal to fresher, even they have 5 years of experience, because they are not aware about the methodology. Try to understand, if you are writing one mux program, okay, so you might have your own methodology, I might have my own methodology, मेरा अपना तरीका हो सकता है, आपका अपना तरीका हो सकता है. So there will be no compatibility. So for that only, UVM is introduced by top EDA industry only. Okay, and they introduced universal methodology. That means all company has to introduce that universal methodology only. So after that, what happens? If E1, E2, E3 are working with a different employer, then also they are working on a common methodology. They are working on SV only, but the methodology is different. That means उसका तरीका, जैसे कि एक component है test bench, so they are aware about test bench. This is standard, this is universal name. Component, let's suppose they are talking about interface, they are talking about the TLM ports. Okay, that means it should not be specific to any language, it should be universal. Like that, we have ports in the adapters. So you saw sometime USB. Okay, so universal bus, that is. So what is the purpose of having universal? Because to increase the compatibility, that's all. Okay, now how the SVM and UVM is. So one second. So you can just go through the VLSI for all app, you will find the basics. Okay, but I will not play the video for now. You can just go through this in the module, just to show you the index. Okay, just to show you the index. If you will see, these are the data types which will only introduced by system Verilog. These many things. Okay, these many things, interface and class, and then these concepts, right? These are the constraint and many things. And similarly, if you will change the methodology, if you will change the content from this to UVM, then you will find out. Okay, if you'll see the what is the UVM, so this is a universal methodology. So you will just find out these many things. Okay, VF phases, VF phase X. So these are the separate modules. So if you are thinking to be a verification engineer, you should be 100% in this system Verilog as well as UVM. But if you are planning to become a design engineer, then Verilog is must, but kind of enough. But Verilog is must. And if you are planning for DV, so Verilog, SV, and UVM all are must. Okay. So if I plan to show you the same test bench with system Verilog, so it will not possible for now because it will take lots of time. Okay, need to prepare that. But let me show you the codes if I have, how it will be on the 1 minute. Vending machine. See. Yes, so this is the code for UVM. Okay, so here you will, if you will see, so everything is standard. So first we are including UVM macros. Okay, then we are importing UVM package. So now if you will see code of any company, if you will randomly go to, let us suppose Broadcom, and if you will open their code, so they will have only these keywords. They will have they need to extend class from UVM sequence item only, because it's a universal. Even each component name is start with UVM underscore only to make universal. Now, if that candidate will leave Broadcom and will join Samsung, so he's already aware about the what is UVM sequence item. It is not Samsung underscore sequence item. It is not Broadcom underscore sequence item. It is UVM underscore sequence item. So it is universal. And now you can extend, you can give their own name here. So that is the power of UVM. Okay, everywhere you will see UVM sequence, everywhere you will see UVM sequencer, UVM scoreboard. So they are universal names. Okay, universal write method, UVM face, UVM, everywhere you will find UVM monitor, UVM mod ports, UVM face, right? So everywhere UVM driver, UVM, these are the face, UVM agents. Everywhere you will find UVM underscore environment. So now what happens? There is no difference. Signal may change, but the overall structure, that is nothing but test bench architecture will be same. Okay. So let me just give you a brief idea of the test bench architecture, how it looks like. If you will see in the test bench, so what happened in the Verilog, this is Verilog test bench, and this is DUT. This is DUT, and this is Verilog TB. Now what we are doing? We are linearly driving inputs. That's all. We are linearly driving inputs. That's all. In the Verilog, which we saw. But what happens in the system Verilog? What happens in the system Verilog? This is our test bench in system Verilog, and this is the DUT. So what we will do? This is the interface between our TB and DUT. That means it will do communication. It will communication between TB and DUT. Now what happens in this? We will make sure we have the component, and their names are, first we have a generator, which will generate the stimulus. Then that generated stimulus will be drive to the interface, so that it should be reached to the DUT. So it is like that. 1 minute. So it is like that. Now what happens? Whatever data we generated, that is available inside DUT. Now data is available. Now what we'll do? So we will take output. That means we will monitor the outputs from DUT. And we should have a reference data. That means we should have a correct data. And then we should have a comparator. Now we will compare the data, whatever is coming from monitor and whatever is coming from the correct data. And if both data match, then we will say data matched. Else we will say design no match. That means mismatch. So this is, in short, how is the system Verilog test bench? How is the system Verilog test bench? Fine. So I think that's enough for now, because if I will talk about UVM test bench, so you will not able to understand, I guess. But those basic things are available in our apps, so please go through that. And I think up to here it's fine from my side. So if you have any query and anything, so you can ask from starting to last, and then we'll conclude for today's session. So now window is completely open for all. If you have anything, you can ask.
Mm. Anyone have any doubt now? Anyone any doubt? Okay, let me turn on camera. So anyone have any doubt now? Anyone of you have any doubt? Okay, I will take the YouTube doubt sessions also. So basically, just download the app. There are a lot of free classes in the app, right? Like basics of system development, physical design. There are a lot of resources in the app, right? You can download the app, and the app is available on Play Store, App Store, Windows also. Fine. So let me pick the doubts from. You can drop your doubts. You can ask here also. Let me tell one by one. Abhay, Akash, Lakshmi Priya, any doubt? Ankit, any doubt? Asutosh Mishra, Atul, Bala, Rahul. Anyone have any doubt? Ganesh, Jaya, Kiran. If you have any doubt, you can ask right now, or you can later also. You can WhatsApp us within 2-3 days. We will going to call you. Naman, any doubt? Suresh, Shubham, Tanushri, Vatsal. Okay, if you have any doubt, you can unmute and ask directly. You can unmute and ask directly here itself. So, okay, on the YouTube, we have some doubts. Pressure, which job is best? So, first job is design and verification is best if you like the coding, because maximum jobs in this area. Second option is physical design if you don't like the coding. After that, analog layout, analog design, DFT, all other jobs are also there. But the job maximum in this design and verification, then physical design, and then other jobs. Next query is, do you provide placement assistance for the analog layout? Every course have the placement assistance as per the company policy. Job assistance means, okay, which course is best for the analog layout or the physical design verification? So both the courses are fine. Both the courses, analog layout and physical design, are fine. It depends on your interest. Go through the free classes. We are giving the demo class for both the courses. You can go through the free classes and after that take your decision. Cost and all, it is mentioned in the app. Discount and all is also there. Skills for design and verification engineers. Main skills is digital electronics, Verilog, system Verilog, UVM, and protocol implementation like UART, I2C, AMBA. At least 2 to 5 protocols should be mentioned in the resume with the coding part. What is the exact syntax of Verilog? Okay, we have shared the link of the free classes of Verilog in the group. You can just go through the free classes. There we have mentioned everything. Also, please explain UVM test bench. So it is not possible right now, but because time is limited, but I will share the link of UVM test bench in the group itself. Fine. So sir, you can explain the UVM test bench also in 5 minutes if possible. Right now we have 5 minutes also. Ankit sir, are you there? Ankit. Or mentoring is provided free of the cost, or yeah. So mentoring is providing free of the cost. We are not charging anything for mentoring and free courses, but complete courses are paid. Like 6 months, we are charging for the 6-month courses. Those are paid. Ankit, are you there?
Yes. Okay.
Yeah,
Shall I
you
start?
can. Yeah, you can share the screen and tell UVM test bench also in 5 experiments.
Okay. So what happens with this system Verilog test bench, we will able to verify entire test bench. Okay, there is no restriction. There is no restriction, and smoothly and perfectly we will be able to verify. And there is a reusability as well. But what is the disadvantage and where is the gap? So the gap is only in the compatibility with one industry to another. Let us suppose if this is in the Intel, they are using this one, and in the NVIDIA, if they are using same system Verilog test bench, but instead of this monitor, they are using Intel underscore monitor, and NVIDIA, they are using some graphics capture, something that random name they are giving. And it's not only about name, actually internal configuration mainly I am talking about, which I cannot show you now. So that's why I'm talking about name only. But the main thing is the component. Let us suppose they will merge both the components. They will merge both the components, and they will just give another name, which is generator plus driver. They will give another name, which is uh, um, let's suppose super driver. Let's suppose super driver. Yeah, auto driver. Yeah, auto gen, something like that. So now name is also changed, functionality is also changed. Now which is 5-year experience on this super driver, and will go to the NVIDIA, and they will come to know there is no super driver there. There is no generator, there is no driver, some another component which is graphics coder, and the functionality is also slightly different. So that's all. Okay, so for that purpose we have our universal methodology. Okay, universal methodology, and there everything is universal. That means the name, the component, you cannot change. So we have test as a top component, then we have UVM underscore environment, and every environment only contain agents. Agents can be multiples, but it will contain only agent. That means UVM underscore agents. Now inside agents, you will have your driver, monitor, and sequencer. That means UVM driver, UVM monitor, and UVM sequencer. So similarly, UVM driver, UVM monitor, UVM sequencer, UVM driver, monitor, and sequencer. So now this structure is universal. This is same, and currently the same structure is used by all industry. So there is no compatibility gap. This is nothing but our DUT, and this is nothing but our DUT, and they should be connected with the interface. Okay, interface. And we are having, instead of generator, here we are having UVM sequence. So this is the standard which will followed by all the industry. And if we require multiple agents, so we can just increase the count, because our universal test bench is reusable. We can reuse, and we can configure. Configure means we can increase or decrease the agent count. That means number of agents we can increase or we can decrease. It is like that. Okay, so I think that's all is the first impression of the UVM test bench which we can have. So the main difference is functionality wise there is no difference, but the syntax wise and the name wise, the architecture wise only they are differ. With respect to DUT, in one line, what I can say, in all the test bench, DUT will receive the data as a input and will give output. Okay, and then we need to compare. So that's all. So that's all. If anyone have any doubt in this, you can ask. No doubt? Okay, if no doubt, and if detailed or further session, we may plan later if time allows us. Okay, so we can have
If
further
anyone have
plans
any
for
doubt, you
test
can
bench.
unmute and ask directly. If anyone
Yes.
have any doubt, you can unmute and ask directly here. Otherwise, I will write my WhatsApp number also, or you can WhatsApp us anytime.
Yeah, dear students, if you have any queries, please raise it.
Also, thank you VIT Vellore, NSIT Training and Placement Center, Dr. B.R. Roy Engineering College, and one more college is there. Sorry. BPR BVRIT Hyderabad. Yeah, thank you so much. Thank you all the colleges for the session. Okay, thank you, sir. Thank you. Thank you,
Thank you.
Shivas.
Thank you, Rajat. Thank you, Ankit.
Thank you.
Thank you.
So probably we'll
Thank you.
plan for physical events.
Sure, sir. Sure.
Yeah.
Thank you,
Thanks,
sir.
thanks a lot.
Thank
Thanks,
you.
students.
Thank you, students.
Thank